everyone. It's a pleasure to be here in Riyadh to tell you about some of the work I've been doing with my team at SingularityNET on creating decentralized artificial intelligence and building blockchain infrastructures to power decentralized AI. I've been working on AI since I got my PhD in the late 1980s and thinking about AI since the early 1970s, really. But it's never been a more exciting time to be doing artificial intelligence. And I think we're now in the middle of the first of a series of AI revolutions, which I think of as the narrow AI revolution. What we're seeing now, AI is being rolled out across every vertical market, but the AIs that are being created, they're doing amazing things, but they're doing very particular things, right? Each AI will drive a car, it will play a game, it'll optimize a supply chain, but each AI is serving its own function in the context specifically created by humans. And what we're verging toward is the next in the series of AI revolutions, which is the AGI, Artificial General Intelligence Revolution, which will involve AIs that can learn, generalize, imagine, and create more like people. Each AI in the AGI phase, each AGI can carry out multiple different tasks and can carry out new tasks that it was not programmed, trained, or prepared for. And as we verge from narrow AI on toward artificial general intelligence, we're setting the stage for the next AI revolution toward artificial superintelligence, AIs that go far beyond the human level in intelligence. But what I want to focus on now is the transition from narrow AI to artificial general intelligence, and in particular the infrastructure that this swarm of AIs that's taking over the world's economy, the infrastructure that this swarm of AIs runs on. And this is a lot of what I've been working on in the SingularityNET project. We've built a platform using the blockchain that allows a collection of AI agents to coordinate together, communicate together to solve problems in a way that has no central controller, but it's a decentralized, self-organizing network of AIs. And I think this is important for a number of different reasons. I mean, it's important for maximizing the intelligence of the network, because it means the network can self-organize and adapt to new situations in a very flexible way. It's also important for making sure that no single party controls the whole world's AI, but the world at large guides the advancement of AI in a more holistic way. So the SingularityNET platform I've been working on with an amazing group of colleagues since 2017. It's a network of AI agents living all across the blockchain. The AI agents can communicate with each other, outsource work to each other, gather together to solve problems. Anyone in the world can put an AI online in the SingularityNet. It broadcasts there using the blockchain-based protocol, and it can join the decentralized AI network. And we have a whole community of developers and users and customers that is accumulating around this, and they're guiding the growth of the network in a participatory and democratic way. So this is a blockchain and cryptocurrency based system. There's a crypto token called the AGIX token, which is used for payment, reputation rating, and a bunch of other purposes. And this is a network that runs on top of an underlying blockchain. And part of what I'm going to talk about today is the improvements we need to make to that underlying blockchain in order to make this AI network layer really work effectively. Just to briefly illustrate the kind of synergy among different AI agents you can get here. So imagine you have one AI agent that summarizes documents, one that summarizes text, and one that summarizes videos. When you feed a document to an AI agent to summarize, if it encounters a video it doesn't understand, it can then outsource that to another AI agent that summarizes that video. If that video contains conversation in say, a dialect of Arabic it doesn't understand, the agent processing the video could outsource translation from that dialect of Arabic to another AI agent, right? So a whole bunch of AI agents on the back end, which may be coded by different people and living on different machines all over the world, can cooperate to answer one user query, right? And then many more complex examples along the same lines could be articulated. But the idea is no one guy, no one company needs to create the global AI mind. Different people and organizations can put different AI agents based on their own expertise. SingularityNET protocols allow them to cooperate together to solve problems, right? And so at SingularityNET, we're building this platform for decentralized cooperation and coordination of AI agents, and we've also seeded a number of different projects that are using this platform to do specific things, right? So we have a project called NewNet that allows decentralized AI processing to run on phones or embedded devices or internet switches. A project called Singularity DAO that uses decentralized AI for decentralized finance, for trading and prediction of altcoin prices. I mean, harking back to the previous talk about Magic Leap, we have a virtual world project called Sophiaverse, which has avatar versions of the Sophia robot, which is our humanoid robot, the world's most realistic humanoid robot, who was made a Saudi citizen actually in 2017. But she's also a citizen of the metaverse, right? And we have a virtual reality version of Sophia living in our AI-powered metaverse, the Sophiaverse. There's a project called Rejuve, which uses decentralized AI on SingularityNET to study data from people's bodies and help to optimize their lifespan and their health. And of course, this is just a few of the projects being built on top of SingularityNET platform. The goal is for decentralized AI to be the underlayer for the global AI economy, which of course is rapidly becoming the whole global economy. I mean, all of these projects are amazing. I want to highlight in particular Awakening Health. You can look at the website awakening.health, and this is Sophia's little sister, a robot named Grace, who is being customized as an elder care robot, which I think can have a very big impact in this COVID era, where there's a bunch of elderly people who are lonely in various care facilities. Of course, a robots company doesn't substitute human company, but it's an interesting augmentation to human company. We think can provide a lot of value. So all these different applications across vertical markets, they're running on the same decentralized AI platform, SingularityNET. Now, the SingularityNET platform itself, which has these AI applications running on top of it, underneath the SingularityNET network, we have a blockchain. And that brings us to really the main thing I'm going to talk about today in the rest of this talk. When we launched SingularityNET, we built it on top of the Ethereum blockchain, which was the first blockchain to have smart contracts, which are like persistent programs that can run anywhere on the internet, running secure transactions on the blockchain. We're in the midst of porting the SingularityNET network from Ethereum onto the Cardano blockchain. So actually we're making it multi-chain, so SingularityNET can run on multiple blockchain backends at once. So we're not getting rid of the Ethereum aspect, but we're shifting the weight of our development effort to Cardano, which is a sort of more modern and scalable blockchain architecture. But even Cardano in its current form doesn't meet all the needs we have for building the next generation global decentralized AGI ecosystem. So we're also creating a custom blockchain called HyperCycle, which it's a sort of side chain to the Cardano blockchain. I call it Sidechain++. It really goes beyond what traditional side chains do, but HyperCycle is a blockchain customized for the needs of AI and designed to interoperate with Cardano blockchain. And I think this will give the underlayer that we need to really power the SingularityNET as it needs to be. And So for the rest of this talk, I'm going to explain a little bit about the HyperCycle blockchain, which really is the first powerful blockchain customized for the needs of decentralized artificial intelligence. And I'll try not to get too technical here, but bear with me, and I think you'll see the point by the end. So I mean the goal with which blockchain was developed. I mean, Bitcoin was originally created to be a decentralized money, right? So you have a money that doesn't have to be controlled by any central bank, but it's controlled by all the users of the money, right? And that's an interesting idea. It soon became clear the idea extends beyond money, and you can decentralize AI processing, you can decentralize medical records, you can decentralize operation of hardware devices on the Internet of Things. Anytime you want a collection of software processes that doesn't have a central controller, but is controlled in a decentralized, self-organizing way just by all the software processes in the network. I mean, blockchain will do that for you, and so that's quite interesting. On the other hand, current blockchain technology is too slow and expensive to fulfill the promise and the vision of blockchain. And if you really want to make the whole world economy operate on blockchain, which I do, and many others in the space do, the current crop of technologies isn't quite good enough, and we're running up against that in a very concrete way with SingularityNET. Like with these Grace robots, just as one example. I mean, we want to put all these robots on the blockchain. We want everything a robot sees to be encrypted with the private keys of the people who own the data comprised of what the robot sees. We want the AI on each robot and the AI in the cloud controlling the robot all to be cooperating together to learn from what all the robots see, but in a way that respects the privacy of everyone the robot was interacting with. I mean, this is a decentralized AI on blockchain problem, yet current blockchains fall short of the speed and cost requirements to roll something out like this globally. I mean, we can roll it out now across various hospitals and healthcare facilities, it's good, but if you want this to be in every elder care facility and hospital in the world, we need a greater level of scalability and lower level of cost, and this is why we're developing HyperCycle. I mean, we want to reduce cost, increase speed, reduce amenability to bugs and hacks, and we want a software framework that's easier for developers to work on, to build this next generation of applications. And this gets into some fairly technical points, but for those who understand how blockchains are built, every blockchain that's out there now has a distributed ledger or a replicated ledger, right? So what this means is it's sort of like a spreadsheet. Every blockchain has a spreadsheet, which is an accounting record of all the transactions made on the blockchain. And what makes Bitcoin decentralized is every Bitcoin node has a copy of this spreadsheet that records all Bitcoin transactions ever made. Every Ethereum or Cardano full node has a copy of every transaction ever made on that blockchain. And so that's decentralized because it's not just one guy who has that database. All the nodes have that database. But it's bad, like it's very inefficient because you're making this big database and you're copying all over the place. Every time a transaction is made, it has to be entered into every copy of this database. And so they try to work around that by sharding the database. So you split the database up into pieces, but it's still a bit awkward. And what we do in HyperCycle, using a unique technology called TODA, is we get rid of the ledger altogether. Basically, each participant in the network just has a record of their own transactions. They can share it with their friends as a backup, but you don't need any ledger storing all transactions on the blockchain. So it's a fundamentally different way of using the data structures and encryption technology underlying blockchain, which is just much more efficient because you don't need any of these global scope records of everything that happened in the blockchain. Another innovation is the use of AI to estimate reputation. So some of us actually don't commit fraud and steal people's money and pretend to be things we're not. That can be seen through our interactions. We get a high reputation in the network. and then the system can allow our transactions without as much security checking, where if someone has a bad reputation or is unknown, you do more security checking. So by doing machine learning-based reputation estimation, you can streamline many operations. And finally, if you look inside Ethereum or Bitcoin smart contracts, I mean, it's not terrible software, but it doesn't leverage the latest in computer science theory and mathematics. So by using the latest innovations from functional programming languages and the theory of AI, you can make smart contract languages that are easier to develop in, won't crash as much, or are harder to make bugs in. So we're innovating on the blockchain tech side, we're innovating on the reputation estimation side, then we're bringing a bunch of advanced computer science tools in to the design of the system. And all in all, I think we're creating a blockchain framework that combines multiple powerful components to create something much faster and cheaper to operate, also more environmentally friendly. We don't have the issues like Bitcoin or Ethereum does, where you're just burning up processor time and polluting the environment just to confirm transactions. So this is building on the Cardano framework, and it's drawing some tools from our OpenCog artificial general intelligence framework into a unique blockchain design. And this diagram illustrates some aspects. We have the Cardano main chain over here to your right, and then Cardano has a system called Hydra, which allows other blockchains to relate with the Cardano main chain in what's called an isomorphic way, which means that the smart contracts running on Cardano main chain can sort of port over to the sidechain or other network in a way that doesn't lose information. So we have the HyperCycle nodes interoperating with the Cardano main chain, but most transactions that happen in HyperCycle just stay in HyperCycle. So you could have 1 million AI agents exchanging information super rapid fire in HyperCycle, which is super fast because it doesn't need to maintain a global ledger, right? Then every now and then they can save a snapshot to the Cardano main chain, and it's stored on the Cardano ledger. Then Cardano has a smart contract language called Plutus. We can run the Cardano smart contracts on HyperCycle, but we can also use our AI language, which is called Meta, on top of Plutus to do very efficient implementation of advanced AIs on HyperCycle. So we're leveraging the sophistication of the Cardano infrastructure to create something that's just much faster and more lightweight for large-scale AI applications. And much of the magic here comes from a system called TODA, which was developed by Tufi Saliba, who's the TO in TODA, and Dan Tolliver, who's the DA in TODA. And these guys developed a ledgerless approach to blockchain, which is pretty amazing. I mean, it's based on the concept of a TODA file, which is just a record together with a Merkle tree that stores the history of all transactions related to that record. And by putting the transaction history in the individual file, you get rid of the need for a global ledger like in Ethereum or Bitcoin. TODA has been used in a number of different systems so far, including TODA Q and the TODA network, and there's a whole bunch of different TODA-based systems. We're using the TODA mathematics in a different way in HyperCycle to create this Cardano sidechain. I think it's a very powerful approach. The concept of proof of reputation is also critical, and if you look at Bitcoin as proof of work, where the processor has to crunch a bunch of math problems in order to prove that it's genuine. Ethereum is moving to proof of stake, where basically you prove that you're rich in order to be allowed to perform transactions. We have proof of reputation, where you prove that you've been a reputable actor in the network in your history, and this gives you the right to approve transactions and participate fully in the network. It's all based on Cardano's smart contract language, Plutus, which is really the only smart contract language out there that's abstract enough to support this sort of complexity. You couldn't do this on Ethereum's Solidity network. And then Cardano's Hydra framework is what lets Cardano connect with external networks in a way that is efficient but doesn't lose information. And that lets you run smart contracts that use Plutus together with an abstract AI language like our meta language. And we can then script AIs in a way that's very efficient but also very simple. So that the end result here is we're creating a blockchain system that will let hundreds of thousands, millions, billions, trillions of AI agents running independently across all sorts of different hardware devices, from laptops to servers to cell phones to switches in the internet infrastructure. I mean, an unlimited number of AI processes running on all sorts of devices. Each one is looking at the data local to it. Each one is taking its own actions, doing its own learning and reasoning. They're interacting, they're exchanging information with each other, they're coming together and cooperating to solve problems. The interactions of this unlimited number of AI agents are recorded in the HyperCycle blockchain, which, however, doesn't mean it's stored in some centralized ledger somewhere, right? The HyperCycle blockchain is sharded all the way down across all the unlimited number of AI agents that are involved in it. When they need to, a group of agents can come together and they can back up information in the Cardano blockchain, which has a traditional ledger-based design. The interaction of these AI agents on the blockchain is specified in smart contracts, which use Cardano's Plutus language, and also use OpenCog's meta language, which is designed specifically for efficient execution of AI processes. And I think this sort of infrastructure is, in the end, what you need to make decentralized AI a reality. I mean, you have a tech stack here which has many layers, just like in the traditional centralized tech world, right? So I mean, we have Cardano, which is a fantastic base layer blockchain. We have HyperCycle, which is a ledgerless AI specialized blockchain existing as a sort of enhanced sidechain to Cardano. We have SingularityNET, a decentralized AI network, which is now running on top of Ethereum in the midst of porting to Cardano, after that to be ported to HyperCycle. So we have Cardano, HyperCycle, and SingularityNet. Running on SingularityNet, we have a host of AI tools. We have deep neural networks and evolutionary learning and whatnot. We also have our OpenCog AGI toolkit, which is some unique power generalization and reasoning. On top of these AI libraries built on top of SingularityNet, then we have all sorts of applications. We have the Grace and Sophia robots. We have the avatars in Sophia Metaverse. We have the Rejuve app, which is running on my phone right now, which can track the state of my body through medical peripherals and help me optimize my fitness for longevity. We have AI trading bots running in Singularity DAO, and we're launching within SingularityNet an accelerator program called Deep Funding, Decentralized Ecosystem Project Funding, where we're giving AGIX token grants to entrepreneurs around the world who have cool new projects to propose to build on top of this whole stack that we're creating. So, I mean, I'm engaged with a bunch of teams building some amazing applications, which I've talked about some of. But of course, if we're going to achieve our goal of pervading the entire global economy with self-organizing, decentralized AI, I mean, what we need is literally millions of developers building dApps, decentralized apps, and putting them on top of here. And finally, I want to emphasize a little bit why I'm doing all this. I mean, one reason is it's just super cool technology. It's a lot of fun. amazing to be around at a time when you can actually build stuff like this instead of just daydreaming about it. But I think that the more foundational reason is, while I believe that the creation of AGI with capability at or above the human level it's a virtual certitude at this point. I mean, of course, you know, an asteroid could hit the Earth and it's game over, but assuming nothing really crazy happens, we're going to create machines that can think better than people, just like we've created things that can fly faster than birds and drive faster than people. We're going to create superhuman intelligences. But what kind of superhuman intelligences we're going to create, this is not necessarily yet written, or at least it's not yet written in a language we can understand, right? I mean, we could create a variety of different general intelligences. We could create general intelligences that hate people. We could create general intelligences that don't care at all about people, but can consider us as just an inefficient use of mass and energy. Or we could create general intelligences that view us as their parents and creators and friends, and even if they go beyond us in some way, you know, want to work with us to make our lives as good as possible. So this has to do with what kind of values and what kind of culture go into the general intelligences that we create, right? And I think to get the right values and culture, to get positive, compassionate, loving values and culture into the AGIs that were created, I mean, the right way is not to program my value system or any one person's value system. The right way is to make sure that the AI is developed in a participatory, democratic, decentralized way by all of humanity. So it gets a holistic picture of what humanity is all about by working with people in every country of the world, in every income level, in every vertical market, working alongside people to do constructive and positive things. And in that way, the AI will get a working understanding of human cultures and value. And then as we go from narrow AI to AGI to super intelligence, we'll have an AI that's evolving alongside people rather than as some separate thing that we've created is going its own way, like a rogue AI system. So there's very practical aspects here. I mean, we're doing a lot of computer science. We're building robots, but we're building apps. But all this is being done not just with a practical goal in mind. I think we need to keep in mind the broader set of processes that we're embedded in. And it's amazing to be alive at the time when these sorts of wild visions and ideas tie in with the actual lines of code you're typing into the computer. And it's exciting to be able to tell you all about this. So you can look at SingularityNET.io, and there's a mailing list you can get on. There's blogs and videos and so on. And HyperCycle.ai, you can find the white paper describing this particular project I've gone into today. Thank you.